last topic for today is the Pythagorean Theorem, and this is the Pythagorean Theorem actually. A squared plus b squared equals c squared. Many of you have seen that formula before, and perhaps even used it before, and it's important to note that this is only applicable, or only can be used with right triangles. So this theorem will only work with right triangles. And the whole reason that it's used in the first place is if you know two of the sides of your right triangle and you're trying to figure out the third side. So you can always use this theorem to do that. Okay, so right triangles obviously then will have a right angle. And the longest side of a right triangle is always the opposite side of that right angle. And that is the hypotenuse is what they call that. It's the most important side, and we'll find out why here in a few seconds. The other two sides, they don't have to be the same, but they're called the same thing. They're legs. And those are the two sides that form the right angle. The reason the hypotenuse is important is because the hypotenuse correlates to C in our equation. And the two legs are interchangeable. They can be A or B. It doesn't really matter. So I could call this one A and this one B, or I could switch those around. It doesn't really matter. That's why C is the important side. That always has to be the hypotenuse in the formula. The reason the hypotenuse is the longest side is because it is opposite the side of the largest angle in that triangle, which happens to be the 90-degree angle. The other two angles in there are acute and less than 90 degrees. So the largest angle will always have the longest side on the opposite of it. Alright, so if we know two of the sides of a right triangle, we can use this theorem to figure out the third side. So for instance, let's look at the right triangle on the left side. These are basically the only two situations you can run into with right triangles in the Pythagorean Theorem. We'll put some spin and flare on it next week or tomorrow, depending on when you're seeing this. But these are essentially the two basic situations you can run into. So if we look at the left side here, we're going to stick with a squared plus b squared equals c squared. We do have a right triangle. And we know one side is 4 and another side is 8, and the hypotenuse here is x, and that's what we're looking for. So I can say that 4 is A and 8 is B, or vice versa. It doesn't really matter. The most important thing that I need to know is that this is C. That's the longest side of the triangle and opposite the right angle. Alright, so I would just plug these things into my formula. So if A is 4, I would say 4 squared plus b squared, or 8 squared, equals c squared. And 4 times 4 gives me 16, 8 times 8 gets me 64, and then I add those two together and I get 80. Alright, now in order to solve for c, I need to do the inverse of squaring, which is a square root. So a square root will undo anything that's squared, leaving us with c. Okay, so that kind of cancels that out, or does cancel that out. But then remember, in an equation, I have to do the same thing to the other side. And you could take the square root of 80 and get the decimal, but we just learned how to simplify these things. So what I'm going to do is break down 80. And let's see, we know that 4 and 20 go in there. I know the square root of 4 is 2. And let's break down 20 again. I get another square root of 4 times the square root of 5. And again, I know that this is 2. So these two things are on the outside. Everything's being multiplied, so 2 times 2 is on the outside. And I've got a 5 left over on the inside. So this is what C equals. 4 square root of 5 would be the length of that side. And obviously then, as I mentioned, you can get the decimal too. So that's how you can leave that one. And obviously it'll depend. I mean, if the question wants you to get the decimal, they'll let you know, or they'll tell you to simplify the radical. Alright, last problem here then, and I'll be done. Same type of problem here, except for now we're missing a leg. We are not missing the hypotenuse. So longest side, or the opposite side of the right angle, that's always C, remember. And then I can call call 6 A or B, doesn't matter, I'll just call it B, meaning we're solving for A. So A squared plus B squared, which is 6 for us in this case, equals 10 squared, or C squared. Alright, so then we have A squared plus 6 times 6 is 36, 10 times 10 is 100. Alright, now this is the only difference between this one and the first one is we're going to have to subtract 36 over to get A all by itself, or A squared all by itself. And now, remember, we don't want A squared, we want just A. So I'm going to square root both sides. That's going to cancel out the square. And I'm left with, if you know the square root is 64, which we should, just take it. You don't have to simplify that at all. If you know the square root and it comes out, if it's a perfect square, there you go. So the side of, or that leg is a length of 8 units. And that's how we do that. Alright, like I had mentioned, we'll expand on this a little bit more in class, but these are the two basic types of problems you'll see with Pythagorean theorem.